Welcome to part 4 of the 3D noise Flowfield in Unity tutorial by PeerPlay. In this final part I will show you how to create an audio visualization based on this system. To follow this part you require two things. First, you need the AudioPeer class. If you haven't followed my tutorial series on audio visualization, follow that course to create the AudioPeer class. Second, we will be using the free post-processing stack from the asset store, so import that into your project. In this video I will go through some steps to make this Flowfield react to the piano music playing. So first of all, make sure that you add the AudioPeer to an empty game object into the scene so we can use it for creating audio visuals. So the first thing I want to do is I want to divide all of the different particles to different frequencies. So let's open the Flowfield particle script and we're going to add a public integer. And we'll call this the audio band. And in our script we're going to set every Flowfield particle to react on a different audio band. So let's save this script and go back to Unity. And we're going to add a new script and we'll call this the audio Flowfield. And with this script we're going to control the noise Flowfield script. So let's open up the audio Flowfield. So this script requires the noise Flowfield. So let's say that we require that component just to make sure. So it's going to be the type of the noise Flowfield. Now let's make a reference to the noise Flowfield so we don't have to do the get component all the time. We'll call this noise Flowfield. Now let's also make a reference to the AudioPeer. So let's create a public AudioPeer. Now in the start we're going to assign the noise Flowfield to the get component of the noise Flowfield. So we'll say noise Flowfield is get component of the noise Flowfield. Now I want to create an equal distribution of the frequencies to the different Flowfield particles. So we're going to create a for loop. And we'll say for int I is 0, I is less than the noise Flowfield dot the amount of particles, I plus plus. Now with the AudioPeer class you can either choose to use the 8 different frequency bands or the 64 different frequency bands. For this example I'm going to use the 8 frequency bands. And I want to make an equal distribution. So once we spawn 2000 of our particles, I want an equal number of particles to have on each of our frequency bands. So to do that, outside of the for loop, I'm going to create an integer. And I'll call this integer the count band. And it's going to be 0 by default. Now each time in the for loop, we're going to add 1 to the count band. So count band plus plus. And we're going to use modulo to make sure that this number will always be between 0 and 7 for all the frequency bands, where 0 is the deep bass and 7 is the highest of frequencies. So we're going to create an integer and I'll call this band, and we'll say that band is going to be count band modulo 8. So now what will happen is when this number hits 8, it's going to become 0, 1, 2, 3, 4, 5, 6, 7, and then once it's 8, it's going to be 0 again. So in between of this, we can set the audio band of all the Flowfield particles. So we're going to talk to the noise Flowfield, and we want to get the particles list of its current position in the loop. And we want to set the audio band to become the band. Now this entire thing is happening in the start function, and in the noise Flowfield we'll also set everything up in the start function. Now I want this to happen afterwards of the noise Flowfield, and to do that we can set a script execution order, but for this example I can just change this to awake, which means that this will happen in front of the start function in this script. So I changed this to awake. Let's save that and go back to the audio flow field, and let's save this as well. Now to make sure that this is working, let's check it out in Unity. Let me play the scene. And now if we click on the particle cubes, we can see that there's always a different number in the audio band here. So this is 5, 7, 2, 6. So all these particles have a different audio band to respond to now. Now it's time to script out some behaviors of the particle flow field to react to audio. So let's start off with setting the speed based on the incoming audio. So we've set up here the particle move speed and the rotate speed. And we're going to change these variables based on the audio. So let's open up the audio flow field. So let's add some variables for the speed purposes. And for that I'm going to create a header, so it's going to be easier to see which variables are for what. So let me type here header, open parentheses, and we'll call this speed. Now all the variables underneath here are going to be about the speed. So let's first start by creating a boolean whether we want to actually use this speed on audio. So let's create a public bool and we'll call this use speed. Now we're going to create a lerp between a minimum speed and a maximum speed based on the frequency incoming audio. So we're going to create two new public vector thus, and we'll call this the move speed min max. And let's also create the rotate speed min max. Now to the update, we're going to say that if the use speed boolean is true, and then we want to set the movement based on audio. So here we're going to talk to the noise flow field and we'll get the particle move speed, and we're going to set that to lerp between something and something. So we're going to say mataf.lerp, and we'll lerp between the move speed minmax.x to the move speed minmax.y, and we want to do this on audio. So let's get the AudioPeer class, and we'll set this to the amplitude buffer, which is the total amount of amplitude of the song playing. And this is a float value between 0 and 1, so this will lerp between this value and this value that we can specify in the inspector. Now let's also do the same for the rotation speed. So we'll get the noise flow field dot the particle rotate speed is mathav.lerp, and we're going to lerp here between the rotate speed minmax.x, the rotate speed minmax.y, and we'll get here the AudioPeer dot amplitude buffer. Let's save the script and go back to Unity. Back in Unity we have to still specify the AudioPeer slot, so let's drag and drop this AudioPeer onto that, and we're going to use the speed. And right now the particle move speed is at 40, so let me just say that we're going to go between a minimum of 0 to a maximum of, well, let's do the double of it, 350. As you can see, it's already working and it's visualizing the music through the speed of the particles, and the particles decrease and increase their speed based on the total amplitude. But we want to do more than just this, so let's add some more effects to these visuals. The next thing we'll add is to make the particles scale to the audio as well. So let's open up the noise flow field, and we're going to change this line in the update where we've set the transform.local scale, because we're not going to do that in the update of the noise flow field, but we're going to do that in the audio flow field. And let's use for this example the different audio band groups that we've set up. So let's create a new header, and we'll call this scale. Now let's create a public bool, and we'll call this use scale. And we'll set up here a public vector2, and we'll call this the scale min max. Now we're going to set this scale to each particle, and depending on the audio band that we specify to the particle, we'll set the scale to that. So we need to make a for loop to loop through all of the particles. So we can copy paste this for loop here. Now inside this for loop we're going to check if we're using the scale. So if use scale, if that is true, then we're going to apply the scale. So let's create a float and we'll call this scale, and we'll do a mathf.lerp on this, and we're going to lerp from the scale min max.x to the scale min max.y, and we're going to lerp by using the AudioPeer, and we'll get the audio band buffer in this example. And the audio band buffer exists out of 8 different float values from 0 to 7. So we're going to set this to the specific particle of the noise flow field. So we're going to get the noise flow field dot the list of particles, and we want to get the particle of the for loop, and we'll get the audio band of that. Now let's apply that to the local scale. So we'll say noise flow field dot the particles list of its position dot its transform dot its local scale is going to be a new vector3, and that will be the scale scale scale. Now let's save this script and go back to Unity to check that out. Now let's take on the use scale, and we're going to scale between 0 and let's say 3. So now what you can see with these two different things combined, you can see that they are moving in a different speed on the audio, and also based on the individual frequencies they are growing and shrinking in size. Now what I want to do is actually change this to spheres, because I think they're more aesthetic. So let's go over to the flow field. We've got the particle cube here. Let's go to game objects, create a new 3D game object, and we'll create a sphere. We'll remove the component of the collider, and let's add the flow field particle to it. I'll call this the sphere particle. Let's add it to the prefabs. Now go to the noise flow field, and we're going to select that instead of the cube. Remove this one from the scene. Let's play that. Now we can also live play with these variables, of course. So if I change this up a bit more, they'll grow more. Very cool. Alright, let's continue. So far we've set up the speed and scale to react on audio, and now let's also create a material that reacts to audio as well. So let's create a new folder, and we're going to call this materials. Now inside of the folder, let's create a new material, and I'll call this a particle material. We will be using the standard shader for this one, and I'm going to tick on the emission because we're going to set the albedo and the emission color to audio. Now before we're scripting out the materials on audio, let's set up the scene so that the camera is in the correct position. So I'm going to go to play mode, and I'll select the camera and I'll rotate this to its correct place. So let's rotate this. This is got to go like 90, minus 90. And let's put this a little bit backwards. Let's see. Back. To there. Well, alright. So now I'll copy this component, go out of play mode, and it won't save the locations, but I've copied the component and I'll paste the component values. And now I've got a correct position for the camera. Now let's go over to the noise flow field and let's open up the noise flow field script. And we're going to add a list containing all of the mesh renderers. So underneath this list I'm going to say public list, and we're going to call this the mesh renderer, and this will be called the particle mesh renderer. Now I'm doing this because we don't want to get the component of the mesh renderer in the update, so we're going to set this in the noise flow field script in the start function. So in the start function, or in the awake function actually, we're going to specify that the particle mesh renderer is a new list of mesh renderer. Now in the for loop we're going to say that where we are adding to the flow field particle, we're also going to add to the particle mesh renderer. So we'll say particle mesh renderer dot add, and what do we want to add? We want to get the particle instance dot get component mesh renderer. Now let's save this script and go to the audio flow field. Let's create a new header, and we'll call this header the color, or actually let's call this material. Now let's create a reference to a material that we can specify to use. So we'll say public material, and we'll call this material. And in this script we're going to instantiate 8 different materials, and we'll apply them to all of the different flow field particles, because we don't want to create 2000 different materials, because that will take a lot of memory. So let's create a private material array, and we'll call this the audio material. And as we are setting 2 different colors, let's create 2 different booleans for whether we want to use those colors or not. So create a public bool, and we'll call this boolean use color 1, and a new line for public boolean use color 2. Now let's create a gradient so we can set all the different colors at once in the inspector. So we'll say public gradient, and we'll call this gradient 1. And for the other color we'll create a public gradient, and this will be gradient 2. Now we need to translate those gradients into colors, so let's create a private color array, and I'll call this color 1, and for the other one I'll create a private color array color 2. Now we don't really have to do this with 1s and 2s, but the way I'm setting this up means that we can set a different color for the diffuse color or albedo, and a different color for the emission. Now let's create a few more variables for each of the colors, and that will be the threshold, whether it's going to be a color or totally off color, and a multiplier on the color. So let's create a public float, and we'll call this the color threshold 1, and a public float, and we'll call this the color multiplier 1. Let's do the same for the other color, so copy paste, and I'll change this to a 2 and a 2. So let's set all these things in the start function. So the audio material is going to be a new material with the length of 8, and the color 1 is going to be a new color with the length of 8. Color 2 is going to be a new color with the length of 8 as well. Capital there. Now we have to set all these colors to the gradient positions, so we'll do this in a for loop. So for int I is 0, I is less than 8, and I plus plus. So we're going to say that the color array 1 of its current position is going to be the gradient 1 dot evaluate, and this evaluation is between 0 and 1, so we need to divide this by 8, so we'll say 1f divided by 8f between parentheses, and we're going to multiply this by I. Now let's do the same for the second color. So we'll say color 2 is gradient 2. And next thing we need to do is set the audio material. So we're going to say audio material of its position is going to be a new material based on material. One more thing we have to do in the start function is assign the material of each of the particles to the corresponding band. So let's talk to the noise flow field in this for loop, and we're going to get the particle mesh renderers that we've created, and we're going to get the position in the loop, and we want to talk to the material of that, and it's going to be the audio material. And which audio material we want to get the band. So now let's go to the update. Let's create a new for loop. So for int I is 0, I is less than 8, I plus plus. Let's start by doing a check that if we're using the color. So if use color 1. Now for this example I'm going to hard code whether to use the audio band or audio band buffer, and in this case I'll use the audio band buffer, so we're going to check if that is above the threshold. So if AudioPeer dot the audio band buffer of I is above the threshold 1, then we're going to talk to the audio material array, and we're going to set the color on the shader of that material. And here we need to specify the name of the material, but instead of hard coding the name of the material, we're going to add a few more variables. So let's scroll to the top. So right underneath the boolean use color, we're going to create a public string, and we'll call this the color name 1. Now let's do the same for the second one. So underneath this boolean we're going to say a public string color name 2. By doing it this way we can change the shader of the material and just change the names corresponding to that shader variables. So let's scroll down again, and we're going to set the color, instead of a string we're going to set it to color name 1. Now to what color do we want to set it? We want to set it to the color array, so color 1 array of its position in the loop, and we're going to multiply that by AudioPeer dot audio dot the audio band buffer of the position in the array multiplied by the multiplier 1. Now if it's under the threshold we're going to set this to black. So let me copy this statement up until this point, and the way we can make it black is just multiply this color by 0f. Now let's copy paste this entire if statement, and instead of using color 1 we're going to use color 2, and instead of using the audio band buffer we're going to use the audio band, and we want to check on threshold 2, So the audio material will be set to color name 2, color 2, and this we want to change to audio band, and the multiplier will be the multiplier 2. And here we have to change it to color name 2 and color 2. Now with that in place, let's save the script and go back to Unity to check out the materials. Now we need to specify all these variables, so let's first select the material. So we've got the particle material here and put it in this slot. We're going to use color 1 and color 2. Now we need to specify some gradients, so you can create your own gradients. I am going to select something I've already created here. So this is a nice rainbow. And here's another one for the emission, because I'm going to type here that the color 2 is going to be the emission color, as this is the name of the emission color in the shader, and for the albedo we'll use the color. When I see that I forgot to make a range of the color threshold, so let's do that, which is a bit more easy to do. So for the color threshold above it, we're going to say a range between 0 and 1. 0F and 1F. Now let's do the same for the color threshold 2. So above there, put the range, save it, go back to Unity. And now we see some sliders here. So I'm going to set the color multiplier of the normal color to 1, and it won't have a threshold. And I'm going to set the emission color multiplier to 3, and it has a threshold of 0.5. While we're at it, let's also add some post-processing behavior to the camera. So we're going to add a component post-processing behavior, and let's create a profile. So we're going to create a post-processing profile. I don't care about renaming it. Let's put this onto a behavior, and we're gonna take on bloom. Let's put the radius a little bit higher. Intensity. Oh, let's see this. Okay, it's working. It should be tweaked a little bit more though, but they are reacting, and see how we just combine 3 different things like speed, scale, and color, and you get a beautiful visualization. Now I'm going to leave it at this point. I've given you an introduction on how to create these visuals based on this Flowfield. You can of course add some more things to the offset speed to make that work on audio as well, or maybe change the increment on audio, or you could change some of the behaviors of the Flowfield. For example, if the particles hit the outside, what will they do? Right now they spawn on the other side, but you could also make that if they're outside they will rotate towards the center of the cube deck, so they don't really respawn to the other side. So many possibilities, but I'm not going to get into that, and this video became too long already. Somewhere in the near future I will release a professional version of this system, which will be exclusively available for patrons on my Patreon. If you wish to support me creating these tutorials, you can become a patron as well and get access to the source files of the tutorials. Thank you for watching this tutorial series. I will be working on new interesting subjects. Hope to see you again.